morning. Hope this screen is visible.
Yes, sir.
Yes, sir.
Then. Welcome back to the last class of SS. Usually we'll close the SS discussion today. So from tomorrow onwards, the ball is in your court. I want all the students to revise whatever we discussed. We'll come back to that, how we'll be doing that. But before that, so let me have a quick recap on where we were and where we will be going today. So we have discussed in detail about the compilers. We looked at various stages and how the compilation takes into the high-level languages. Maybe the three important stages like lexical analysis, syntax analysis, and code generation. We have touched upon very important concept of a code optimization, both at mission dependent level as well as mission independent level. In that, intermediate code was playing an important role, and removing of duplications was also important for us, and these things have made us to have a better or efficient code as far as the final object code was concerned. Now today we'll have a discussion on various compiler design options. If you look at compilers, we have seen earlier an absolute compiler where the program gets loaded into the place where it is supposed to be, as absolute loader says, and a compiler of an absolute nature is one which loads the entire program into the same place and make sure that that particular compiler is very smooth. And we have seen bootstrap compiler, bootstrap loader as well. That bootstrap loader was mainly to implement various what you call OS related activities at the loading level. They are with respect to the loaders. So what you call a loader of a bootstrap category, or maybe autonomous type of loaders which were there for the loading purpose was different. Today we're in compilers. A compiler is generic in nature, and we have seen the various compilation stages that were part of the compilation process, those three stages. Okay, so we have not discussed any specific compilers as such, but we know that C, C++ are a basic compilers or high level languages which you have been using for maybe a decade. At least you have been experiencing this. So no confusion now between a loader and a compiler. Loader is only for loading. An absolute loader or a relocatable loader or a linking loader or a dynamic loader, they're only from the loading purpose. So we have seen so many design options, right from assemblers till loaders. So absolutely each one of them is a unique piece of code. If you take assembler, they're unique. Linker loader, they are unique, and macro processor, they are unique. And today we talk about the compilers, totally a different ball game altogether. So when it comes to the design options of a compilers are purely of high level language nature, and there might be some confusion maybe between an interpreter and compiler, because many times people use these two interchangeably without knowing much clarity or difference. But probably today is the time where we need to look at those confusion level and make sure that we'll never have confusion, at least from now onwards. So we have compilers which are mainly for, as we know, taken high level language, process that, generate an intermediate code called object code, then go for execution. This is a process of compilation, whereas interpreters slightly differ from them. So like this, we'll be seeing some of the P code compilers which we normally see in Java bytecode. And maybe ACK we have already seen, ET compiler, another compiler. These are the various variations what we can see as the design of compilers are concerned. Probably we'll touch upon these 2 or 3. Maybe we'll have a couple of assignments on the real-time compilers like Sun OS compiler as per the syllabus. So before we get into, let us look at the interpreters as a first design option. So interpreters also a type of translator which looks similar to compiler, but definitely there are some differences or conflicting points between a compiler and interpreter as well. Let us see to avoid any confusion at this point of time. So compiler, again to reiterate, the definition of a compiler is, or the process of compiler is, to have a high level language program, process that. How to process? Those 3 stages minimum, or there are 6 stages if you go in deep, but overall there are 3 stages: lexical analysis or a scanning, syntax analysis or a parsing, and a code generation. That is the second stage. Once that is done, as a third stage, object code will be created, and as a fourth stage, we can go for the execution. When it comes to the interpreter, we'll have a high-level language, which is pretty same as a compiler. It will be processed, where we have 3 stages in the compiler. Interpreter will have its own stages, but processing is going to happen. But the difference here lies here now. There is no intermediate code that is getting generated here. In the compiler, if you know, a code generation stage is there, intermediate code, object code is generated, then we'll go for execution. Whereas in the case of interpreter, there is no middle intermediate code coming into picture, but directly we'll be sending the program for the execution. That is the difference between an interpreter and compiler to start with on a higher level. Okay, so let us see in detail how that can be. So if you look at the compiler now, as we discussed, we have a source code that goes to the compiler. Source code here is high level language. And the mission code is generated, which is an object code as an output. Whereas in the case of interpreter, you have a high level language again, but it is an interpreter that process, no problem, instead of compiler. But directly we will go to the execution stage, but there is no intermediate program coming into the picture. That is the first and main difference. Then we'll see how the process takes place. When it comes to the process, let us look at the key differences. So as we know, both interpreter, compiler are meant for processing or translating a high-level language directly into execution stage. Maybe internal process might be different, but this is how precisely a common, we can say, a common type of process or a common type of activity that exists between interpreter and compiler. So if you talk the commonality between these two, yes, both have the same purpose. What is the purpose? They take the high-level language, they process that so that the whatever the outcome we have, that can be executed. That is the basis behind both interpreter and compiler. But how they do this is what is going to differentiate them from each other. So first one, when we know the interpreter is not going to create an object code. It will be directly translating each instruction. Whereas in the case of a compiler generates an object code. So for this purpose, what interpreter will be doing, it considers line by line. That means it takes first line, process that, sends to the output. Process the second line, take the second line, process, send it to the output or maybe execution. That's how it goes. Whereas in the case of a compiler, since there is a need for a generation of an object code, it will not be doing line by line. It takes entire program into one module, and that entire program will be subjected for the compilation process, because here the purpose is to create an object code. Since we are going to create an object code, entire program will be considered. So in the case of interpreter, many times people say you are doing as a line by line, whereas in the case of a compiler, you are taking a program as a whole. So that's how things go. So interpreter always considers a line by line processing, whereas compiler considers a complete program as a input or a source program. This is the second difference. So first difference is there is no object program being generated as a middle part in the interpreter, while compiler generates. Second, since object program is not generated in interpreter, it takes one line at a time for processing, whereas a compiler takes entire program at a time. Since one line at a time is taken by the interpreter and it directly goes to the execution, interpreter many times is going to be slower. As far as the processing is concerned. But when it comes to the take individual line, because it takes individual lines are pretty faster. So here you have to be very careful with the words what is mentioned here. So when we have an individual line being processed, interpreter is faster only. Of course, you are taking one line where compiler takes 10 lines. Okay, from that processing point of view, interpreter is faster. But as a whole, in the sense, if I submit a complete program to interpreter and ask interpreter to execute, compiler execute, the overall time taken by the interpreter to execute a program is more, and hence we say interpreter is slower as a whole compared to compiler, because we have used two adjectives here. If you look at processing each line is faster in interpreter. It's simpler, of course, because it is going to have only one line. Whereas in the case of a compiler, Compiler considers the entire program as one particular module, and that is subjected to the compilation. So when you look at the compilation process per se, that process is going to be relatively slower compared to interpreter. But when it comes to the execution, because at the end, the purpose is to execute the program. When it comes to the execution through interpreter, it takes a lot of time because it has to directly send everything to the program, the mission to complete the execution, whereas compiler generates the object code and sends in one go. So compilation process overall, as for execution is concerned, is pretty faster compared to interpreter. But internally, if you look at the processing, interpreter is much faster compared to compiler as far as the internal processing is concerned. Hope there is no confusion. If you have any confusion, please let me know. I'm talking about internal processing, as we have 3 stages in compiler. If you look at interpreter, it is only one line at a time. It will not take much time. And hence, it is going to be faster than compiler internally when you take each line. Whereas in the case of overall, if I give 100-line program, let us say, to interpreter, and I give 100-line program to compiler, if you look at this comparison, interpreter takes 10 seconds, whereas compiler might take 6 seconds. So that is the time what I'm talking it as the overall time. But internally, it may take less time for an interpreter because it has to follow only one line at a time. So don't have any confusion at this point of time as far as this process is concerned. But overall, interpreter consumes relatively more time compared to compiler, simply because it does not create an object code. It has to every time link with the executor, that is CPU. So that is going to take more time as far as the interpreter is concerned. That's why we say the overall execution time is going to be more time consuming than the time taken by compiler in the case of an interpreter. Now, coming to the debugging, since every line is considered in interpreter, it processes. Suddenly, let us say at somewhere in the 5th line, error comes. What will it will be doing now? When error comes at 5th line, it will show there is an error at 5th line, because if it does not, so what will happen? It cannot come back to 5th line again. So as and when the error comes, it will show and you can rectify and go back. So thereby, debugging in interpreting is easy because you are not going to get 100 errors at a time. Whereas in the case of a compilation, since it takes entire program as a one particular module or set, it will process the entire program and you will be displayed a 100 number of errors depending upon the program at a time, where it is our responsibility to figure out. So compilation or compiler may give room for a difficult debugging because it provides so many errors at a time. Whereas in the case of interpreter, as and when the error is encountered at a given line, it will be throwing to us. Unless we cover that, we will not be going to the next line because it is only almost a single scan process as far as the interpreter is concerned. Thereby, you say debugging is going to be simple compared to compiler in interpreter. So these are the various differences what you can look at now. Then program testing, of course, can be done efficiently simply because if you look at interpreters are mainly meant for that purpose only, because one by line we are going to do, and it may take the very less time as far as the testing is going to concern. Thereby, we will be able to do it a bit faster. So interpreter, of course, it is also meant for taking a high level language, converting or translating into mission compatible language, no doubt. But how do they do that is what going to be the process or the concern. In the case of an interpreter, it takes one line at a time, whereas the compiler takes entire program as a whole. And second difference, interpreter never generates an intermediate program, which is object code, whereas the compiler generates an object program as an intermediate one. So while interpreter is processing each line, if any error is encountered, that error will be displayed on the screen at the same time. So thereby, error debugging becomes easier in interpreter than compiler, because compiler displays complete program related errors, not one at a time, but together as a whole. So that may be difficult for the programmer to debug in the compiler. And second, Maybe the next one, the program testing is easy in an interpreter because you will be given one by one, line by line, whereas in the case of a compiler, it is slightly difficult or maybe relatively difficult because entire complete program is going to be provided for us. So any examples if you look at? Yes, interpreter, maybe your Python, maybe to some extent is interpreter language, because nowadays we cannot go with only interpreters or a compilers. That age is over. In fact, when computer industry started with high level languages, it was pretty interpreter only. Later we moved to compiler, but from the Java's environment onwards, it is a both interpreter as well as a compiler, because any one or going with one is not going to be advisable. People are going with a both because we need interpreter as well and we need a compiler as well. So but Java platform was different because the purpose behind Java was to have a platform independency, thereby bytecode comes into picture. But if you look at the Python and stuff like that, even your Ruby Rails, which you will be studying probably in advanced web programming, they're all examples of a your interpreter. So that's what the idea behind an interpreter and compiler is very important from exam point of view. We need to figure out the differences and write the diagram, whatever we have taken just now. Maybe this diagram will help you to identify the difference between a compiler and an interpreter. Any doubts at this point?
No, sir.
Fine. So this is what the uh, direct way of looking at these differences as we discussed. So this we can go through that, but this is what we have mentioned. So probably the examples for interpreter, Ruby and Rails and Python, and we know for compiler it is a CRC++, which we have been familiar. That is the first category of design. One is a interpreter. Next we have a P code compiler. So P code compilers are nothing but your bytecode compilers, that what you see in the Java programs. So they are meant P here for pseudo code compiler. So P has no other meaning except pseudo. So pseudo spelling is PSCUDO, like pseudo random numbers. So P is silent here. So thereby the P comes. Otherwise, it is not going to be anything different. But for you to remember easily, P code is nothing but a byte code compiler, which you see in Java virtual machines or Java compiler interpreter. So they are actually having the combination of both interpreter as well as a compiler. To some extent, they behave like a interpreter because that is required, and to some extent, they also have the process of a compilation mixed into this. Thereby, we have a pseudo machine or a pseudo compiler, which is going to be helpful in providing a platform independent type of activity that we see in the Java system or Java programming concept. So if you look at the processing here, so as we have seen the compiler, no, we have a source program, compilation will come in picture, object code is generated, then we'll go for execution. If you look at P code compiler, source program, obviously your high level language program, it goes to the compilation, which is a P code compiler. Later, P code, which is a byte code we call, will be generated. That byte code will be executed using your P code interpreter. So now both compiler as well as interpreter, both are combined here. Thereby, your Java is the best suitable example for a P code compiler. Okay. So P code compiler, as the name says, pseudo code. So they are not mainly for a particular platform now. So they are for the any platform. So probably if you look at the next diagram, you will be able to understand how Java is going to. So this is actually what is the same diagram I have written, just replicated for your understanding. So source program, compilation is done by a P code compiler. Then object program is created because compilation means outcome should be there. What is outcome? An object program. But this object program is not same as the object program that we get in C or C++, because this is in the form of a bytecode. Bytecode is again we can say bytecode is a pseudocode actually, because it is not either high level language program output or a low level. It is middle. So nobody understands properly. So it has to be converted into machine language. It will be done by the P code interpreter. So there your Java virtual machines and stuff will come in picture. Probably this diagram will help you. So we have your Java code, goes to the compiler. Then we have a byte code coming into picture. So later, your Java virtual machine will enable you to go to interpreter, either Windows or Linux or Mac. Hope this requires a bit understanding on the how virtualization is going to done. So virtualization is going to help you to make sure that these JVMs are going to provide a platform as far as the execution of Java is concerned. So this is how the Java has become a what to call platform independent with the creation of a middle package using both compiler as well as the interpreter. So bytecode is the middle path here. So this can be used on any platform just with the help of a JVM, because interpreter is going to directly convert that into this native platform, thereby platform independency can be achieved. So hope this you are familiar, because Java you have been using for a long time, and this is how the idea behind the Java. So Java is the best example for a P code compiler. Again, P code compilers are very important from exam point of view. You should be able to write what are P code compilers, genesis for this, and this diagram, and how this example of Java can be considered as a P code compiler. So this constitutes the solution for the P code compilers. It is called pseudo because it is not meant for a particular platform. You can use for any platform. Thereby, the pseudo has come into picture depending upon the whatever the native platform you have convert into that particular. Here we have a host platforms, we have a guest platforms. So Windows, Linux, Mac are going to be your guest platforms, and those platforms can be considered for executing your virtual machine, which is a Java virtual machine in this case. So this JVM is nothing but your actually interpreter here. Next, we have a third part, maybe the last point in the design process, which is a compiler. So this is actually the YACC. If you remember, we have done some programs recently on this compiler. So compiler is again a tool like ACK. So ACK stands for a yet another compiler. So this is what we see as far as the compiler processing is concerned. So this is basically a major tool that we use in the construction of a compiler itself. That's what we have seen. So lexical analysis, we have seen lexer or a lex. Syntax analysis or parsing, we have seen ACK, which is a tool that builds your compiler. So thereby compile generation or compiler design can be considered or can be carried out using this small software called as a compiler. So thereby we have these inputs as far as the compiler concept is concerned. So compiler is a tool in line to generate the compiler itself. It may be a mini compiler, we can say. So if you look at that compiler process, it has 3 stages as usual. We have lexical rules. If you remember, we have written lexical and we have written grammar. Semantic routines we didn't write much, but first 2 we have taken care through lex and ACK, and thereby we have got the stage for a compiler, which is a scanner, parser, and code generator. Code generator also we have seen lex.yy.c. So this is how the compiler process comes into the picture. So here it is a completely a automated tool like ACK, which is going to help any compiler in general to build itself. That is, if you want to develop a C compiler, probably we can use ACK as one of the intermediate tool to help the C compiler to build on its own. So that is the idea behind this, and this best suits for a ACK, which is a example which you have seen in detail earlier. So probably you can write the ACK program as one of the examples. Probably we'll discuss more in the revision classes that come forward, so that you'll also have more details about the how ACK programs can be used or how ACK programs can be considered for building this type of tools. So this is idea behind a compiler. So which is an intermediate tool in line to build actual compiler like C, C++, or whatever it is. So to do this, we have these tools like lex and ACK, which will facilitate or enable actual compilation or actual compiler design process to be smooth. So that is idea behind compiler. So these are the 3 basic design options. One is the interpreter, P code or bytecode compiler, or ACK compiler. compiler. So this is how the diagram which we have used already. So with this, probably we'll be able to conclude our compiler process or a compilation module, where we fairly discussed about various stages that occur in the compilation process, like lexical analysis, or scanning or tokenization. Second stage being the syntax analysis or parsing. Third stage, of course, being a code generation, which is the final outcome of a compiler. And we have also seen how this code generation can be optimized to major extent using various methods. And these methods are, in fact, are part of our day-to-day compiler design processes. So with this, we conclude. Probably you can make a note of the questions that might occur as far as the compiler module is concerned. And maybe as the next schedule, we'll discuss maybe a short while from now. So I will give an assignment on this. Maybe by today evening, you will be able to receive an assignment where we'll have some 4 to 5 days to submit, which is going to be final assignment for you as far as the SS program, SS course is concerned. And later we'll check out the program, how you can utilize for next 1 month or so. Okay. So meanwhile, you take these questions. Let me complete attendance by then. May I have your attendance? Asta?
Present, sir.
Abhinav?
Present,
Aishwarya?
sir.
Ambrish?
Sir.
Aishwarya present, sir.
Okay. Anu?
Present, sir.
Arbaz? Arjun?
Present, sir.
Ashok?
Present, sir.
Benita?
Present, sir.
Bhargavi?
Bhargavi present, sir.
Bhavisha?
Present, sir.
Chaitra?
Present, sir.
Debamala Chatterjee?
Present, sir.
Diksha?
Present, sir.
Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Murli Krishna?
Present, sir.
Gangubai?
Present, sir.
Guriya Kumari?
Present, sir.
Harshit? Junjar Singh?
Present, sir.
Kavya?
Present, sir.
Kishore Kumar?
Present, sir.
Lata?
Yes, sir.
Manisha?
Present, sir.
Manjunath?
Yes, sir.
Nayana?
Present, sir.
Nilanjan?
Yes, sir.
Nishant?
Present, sir.
Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka?
Present, sir.
Pawan Kumar? Akash?
Present, sir.
Rajeshwari?
Present, sir.
Rakesha?
Present, sir.
Ramya? Rashmi?
So present, sir.
Ravishankar?
Yes, sir.
Rizwan?
Present, sir.
Vishal?
Present, sir.
Savita?
Yes, sir.
Shruti?
Present, sir.
Sneha?
Yes, sir.
Spurti?
Present, sir.
Srinidhi?
Present, sir.
Srinivas?
Present, sir.
Sunil? Vaishnavi?
Present, sir.
Vinny?
Present, sir.
Sir, Aishwarya present, sir.
ಆಯ್ತಮ್ಮ. Have you copied?